I want you to imagine, just for a moment, that you are piloting a robotic submarine.
Well,
You are miles beneath the surface of the Mediterranean Sea. The pressure is crushing, the water outside is just pitch black, and you are relying entirely on your sub's headlights, right?
right. Just those camera feeds.
Exactly. And you are slowly scanning the muddy bottom,
Hmm.
looking at this desolate deep sea landscape, when suddenly the camera shows you something that honestly shouldn't be physically possible.
It's one of the most wild things you can see down there.
It really is. Below you, resting at the very bottom of the ocean, is what looks exactly like the surface of a lake. Like, it actually has shores, it has visible ripples.
Yeah, underwater ripples.
So you drop the submarine down to investigate, and the hull of the sub physically bounces off this underwater lake, as if you're hitting, I don't know, a second seafloor made of liquid glass.
That's so dense.
Right. And if a deep sea fish accidentally swims down into that lake, it dies instantly.
It genuinely sounds like science fiction, I know. But you are describing a verified geological reality.
Which is just crazy.
It is. That is a deep-sea brine pool. And finding one, honestly, it completely shatters our intuitive understanding of how oceans are supposed to behave. I mean, water shouldn't form a separate toxic lake underneath other water.
It feels like a glitch in the physics engine. And that is the core mystery we are unpacking today. Because to understand why those bizarre, deadly underwater lakes exist, we are taking a deep dive into a highly controversial, yet just utterly fascinating book called Earth, a biography of chaos.
Yeah.
Specifically, we are going to explore its unified theory of geologic history, or UTGH, which was proposed by Darrell Waters.
Right, and our mission today is very focused. We are going to examine how this UTGH framework completely rewrites the timeline and the structural history of the Mediterranean basin.
Just throws the old timeline out the window.
Exactly. It takes these strange, isolated anomalies, like those deep-sea brine pools you mentioned, and attempts to string them together into one massive, cascading, basically catastrophic sequence of events.
Now, to be clear with you listening, our job today isn't to say this theory is absolute fact, or, to dismiss it as fiction either.
Right. We're not fact-checkers today.
No, we aren't verifying it, and we certainly aren't endorsing a catastrophist viewpoint. Our goal is strictly to be impartial guides. We are putting on the UTGH goggles to see the world exactly the way this specific model argues it should be seen, just to understand how it attempts to connect the dots of Earth's really violent history.
I think that's a perfect way to frame it. And putting on those goggles, it requires a massive shift in perspective right away.
Oh, for sure.
Because to understand those underwater lakes today, we have to rewind the clock back to roughly 5,300 years ago,
Okay.
to a time when, according to the UTGH model, the Mediterranean wasn't a sea at all.
Okay, let's unpack that, because if it wasn't a giant body of salt water, what are we actually looking at?
Well, the framework describes it as this lush, low-lying continental valley.
Like a massive basin.
Exactly. In this pre-flood world, the basin was essentially the central lowland of a massive supercontinent. And because it was incredibly deep and completely surrounded by higher land masses on all sides,
It would be super sheltered, right?
highly sheltered, well-watered, and biologically speaking, the most hyperproductive ecosystem on the entire planet. The UTGH actually identifies this exact geographic region as the literal Garden of Eden.
Wow. Wait, so not just like a nice fertile valley that reminds us of Eden, but the actual Garden of
But
Eden.
that is the claim. The text argues that the physical geography described in the Genesis account perfectly matches this pre-flood Mediterranean basin.
That is a huge claim. How does it justify that?
Well, Genesis describes a well-watered garden acting as the geographical headwaters for 4 major rivers, including the Tigris and the Euphrates.
Right. Which we obviously still have today.
Exactly.
Yeah.
And the UTGH model maps those ancient river systems directly to this dense, incredibly humid biological engine of a valley.
Okay, here's where it gets really interesting for me. Because obviously, if you look at a map today, it is not a lush valley.
Not at all.
It is a massive, very deep sea. So, how does the UTGH model get us from this biological engine of Eden to a saltwater ocean?
Right, the transition. It gets there through a sudden planetary-scale rupture of the Earth's crust.
Just a total cataclysm.
Yeah. The framework outlines a catastrophic failure starting up in the North Atlantic. Imagine an enormous, highly pressurized subterranean water chamber beneath the crust that basically just cracks open.
And that crack, that fissure, it races around the globe like a zipper, right?
Exactly like a zipper.
But the immediate problem for our beautiful Mediterranean valley comes from the west, doesn't it?
Yes, it does. That geological upheaval triggers a massive displacement of ocean water. The Atlantic violently breaches the land barrier that separates it from this Mediterranean basin.
And this catastrophic breach, it happens at what we now call the Strait of Gibraltar. Let's visualize that for a second, because the Strait of Gibraltar is incredibly narrow. It's a gap only about 9 miles wide today.
It's tiny on a planetary scale.
Yeah, so I'm picturing the entire Atlantic Ocean being forced through a 9-mile gap. That isn't just a flood, that is like a planetary scale pressure washer.
That's a great analogy. The hydraulic force would be almost beyond human comprehension. Because the valley floor is significantly lower than the ocean level, the water isn't just passively rising, like a bathtub filling up.
Right, it's not a gentle spill.
No, it is a directional blast. You have a high-velocity slurry of water, rock, and sediment moving at unimaginable speeds from west to east.
Which raises a massive logistical question for me. If an ocean blasts through a 9-mile gap and pressure washes the single most lush, biologically dense valley on planet Earth, where exactly does all that biological material go?
That is the big question.
I mean, you can't just erase a continent-sized forest. The actual physical matter has to end up somewhere, right?
It absolutely does.
Yeah.
And the UTGH model provides a highly specific answer for that. The floodwaters scoured that Mediterranean valley from west to east, uprooting absolutely everything in their path.
Everything.
We are talking about every tree, every layer of fertile topsoil, every single planet organism. It all became a moving, continent-scale slurry of biomass.
Just completely bulldozing Eden.
Exactly. But to understand where that slurry ended up, you have to look at the mechanisms of what was happening geologically at that exact same moment, just to the east.
Okay, what's happened to the east?
While the Atlantic is breaching Gibraltar, the subterranean water chambers beneath the Arabian Peninsula are also explosively expelling their contents.
Wait, meaning the ground beneath Arabia is emptying out from the inside?
Yes. And when you remove the pressurized fluid that is physically holding up the crust,
The crust just collapses.
it loses its structural support. So simultaneously, as this massive wave of uprooted biomass is rushing eastward out of the Mediterranean valley, the Arabian and Persian crust is physically subsiding. It is sinking.
Oh, wow. So it creates essentially a giant geological catch basin, opening up just in time for all this debris to arrive.
That is exactly the mechanism. The scoured biomass of Eden is swept eastward and deposited directly into these rapidly subsiding Arabian lowlands.
Like sweeping dirt into a dustpan.
A continent-sized dustpan, yes. And once it pools there, it is swiftly buried under millions of tons of subsequent flood sediment.
Okay, hold on. I have to push back here a little bit because standard geology tells us it takes millions of years for oil to form, usually from like marine algae slowly raining down on an ancient seafloor.
That is the standard model, yes.
You are telling me this theory says a slurry of dead trees and soil turned into the Arabian oil fields in a few millennia. How does the physics of that even work without the massive time factor?
Well, it comes down to understanding what actually converts organic matter into petroleum. Time is a big factor in standard models, but the actual active ingredients are heat and pressure.
Okay.
The UTGH argues that you don't need millions of years if you have catastrophic levels of pressure.
Oh, I see.
By rapidly burying an entire continent's worth of dense biomass under millions of tons of heavy flood sediment, you create an immense pressurized pressure cooker.
A literal pressure cooker.
Right. And under that specific extreme heat and weight, that concentrated organic inventory transformed rapidly into oil.
So we're talking about the legendary Gower field here, which by itself holds roughly 18% of the world's proven conventional oil reserves.
Is the massive.
And the model says that is literally the compressed biological inventory of the Garden of Eden.
That is the claim.
That is a staggering reframing. I mean, our sources included a visual breakdown of the math on this, estimating it takes roughly 100 tons of buried organic material to produce just 1 barrel of oil.
100 tons for 1 barrel.
And we've consumed over 1 trillion barrels globally. The scale of living matter required to create the Arabian oil fields under this model is just mind-boggling.
The scale is astronomical, but the UTGH points to a specific physical anomaly to challenge the mainstream slow marine accumulation idea. They point to something called westward provenance.
Break that down for me. What exactly is provenance?
Provenance in geology is essentially the origin story or the source direction of sediment. The way geologists read that story is by looking at something called sedimentary crossbedding.
Okay, what does cross-bedding look like?
Imagine looking at the side of a sand dune that has been sliced in half.
Okay, I can picture that.
The layers inside aren't perfectly flat, right? They slant in the direction the wind or the water was moving when the sand was deposited.
Like little diagonal stripes.
Exactly. And according to the text, when you look at the physical structure of the rock layers in these Saudi reservoirs, the crossbedding shows directional transport.
So it points back to where it came from.
Yes, the material physically flowed in from the west. It didn't just drift down slowly from the surface of a calm sea over millions of years. The physical shape of the rock indicates it was violently pushed there from the direction of the Mediterranean.
Wow. Okay, so the valley is scoured, the biomass is buried in Saudi Arabia to become oil, and the Mediterranean is now full of turbulent, violent floodwater. But the narrative bridge here is that ripping open the Earth's crust releases an unimaginable amount of thermal energy. The catastrophe doesn't just stop with the flood, does it?
No, it doesn't, because it kicks off a massive atmospheric chain reaction. The flood event itself concludes, but the thermodynamic engine it started is still running at maximum capacity.
And this sets the stage for the Mediterranean's next extreme transformation.
Exactly.
We're talking about the Ice Age.
We are. The UTGH has a very specific mechanism for the Ice Age, driven by that thermal energy you just mentioned. The rupture event released massive amounts of geothermal heat and something called supercritical water into the oceans.
Now, for our listeners who might not be material scientists, what makes water supercritical? I hear that, and I think nuclear reactor.
It sounds like it, yeah. Supercritical water is water deep in the Earth's crust that is under so much pressure and heat that it basically stops acting like a normal liquid or a gas.
Wait, so it's not boiling into steam?
Exactly. It doesn't boil. It becomes this highly energetic supersolvent fluid. And when that breaches the surface, it dramatically and violently warms the global oceans.
Okay, so the oceans are basically boiling hot.
Very hot, yes. But at the exact same time, the crustal explosions ejected huge amounts of volcanic ash and debris into the upper atmosphere.
Which blocks out the sun.
Right, which rapidly cools the air.
So it's essentially like running a blistering hot shower in a freezing cold bathroom.
That's a perfect way to picture it.
The mirror fogs up instantly because the hot water is evaporating into the cold air. But on a planetary scale, that hot ocean evaporation hitting a freezing, darkened sky that creates global blizzard conditions.
Warm oceans plus cold air equals a massive, relentless global snow machine. That is the UTGH Ice Age engine.
Wow.
It wasn't a gradual shift over tens of thousands of years due to subtle orbital wobbles like in mainstream models. It was a rapid, intense thermal reaction that lasted for centuries.
And as it snows relentlessly year after year, century after century, that moisture doesn't return to the ocean.
No, it gets trapped.
It gets locked up on the continents as massive ice sheets, which means global sea levels have to drop.
They drop dramatically. According to the framework, as the ice builds up, sea levels fall by roughly 120 to 130 meters.
So like 400 feet.
Roughly 400 feet, yes.
And here is where the story of the Mediterranean takes another wild turn. Because if the sea level drops 400 feet, that narrow, shallow gap at the Strait of Gibraltar we talked about,
It gets exposed as dry land again.
the connection is completely severed. The Mediterranean is entirely cut off from the Atlantic Ocean once more.
Totally isolated.
So it basically becomes a giant bathtub with the drain plugged and the faucet turned off.
The geological term is a net evaporative basin. The Mediterranean region loses vastly more water to evaporation under the sun than it ever gains from rainfall or rivers.
So cut off from the Atlantic, the water simply has nowhere to go but up.
It evaporates completely.
Wait, I really have to pause here and marvel at the whiplash of this timeline.
It is a lot.
So according to this UTGH model, we go from a lush, hyper-productive garden, right,
To a violently scoured oceanic flood zone, to a bone-dry, miles-thick salt flat, all in the span of a few centuries.
It's a very aggressive compression of geologic time. But the interesting thing is, mainstream geology also agrees that the Mediterranean completely dried up. They just call it the Messinian salinity crisis.
Right, but mainstream science places that event millions of years ago, not right after a global flood.
Correct. The timelines are completely different. But the physical evidence left behind is exactly the same for both models.
Okay, what evidence?
When an ocean dries up, it leaves behind evaporate sequences. As the water evaporates, it can't hold all its dissolved minerals, so they crystallize and fall to the bottom.
Like sea salt left in a glass of water.
Exactly. First, you get calcium carbonates, then gypsum, which is what we make drywall out of, by the way, and finally halite, which is basic rock salt.
Okay.
Today, there are halite and gypsum salt flats miles thick buried on the Mediterranean floor. The UTGH framework takes that accepted physical evidence and just compresses its formation into this rapid post-flood ice age window. So we now have a miles-thick salt flat, just a barren, hypersaline desert where a sea used to be.
Yes.
But how do we get back to the deep blue Mediterranean Sea we know today? Because obviously I can go book a cruise on it right now.
Highly recommend it.
Right. It is very much full of water today.
Well, to get the water back, you have to turn off the Ice Age engine. Eventually, those hot post-flood oceans cooled down.
The shower ran out of hot water.
The shower ran cold, exactly. When the water cooled, that massive engine of evaporation stopped. The atmospheric ash finally settled out, the skies cleared, the sun came back, and those massive continental ice sheets began to melt.
And all that locked up fresh water has to go back into the global ocean basin.
It does. Glacial meltwater pours into the oceans, and global sea levels rapidly rise back up by that same 400 feet.
Which brings the Atlantic Ocean creeping right back up to the doorstep of the Gibraltar land bridge.
And it breaches the threshold catastrophically one last time.
A second massive flood.
Yes. This event is known in geology as the Zanclean Flood. The rising Atlantic spills over the Gibraltar land bridge, rapidly refilling the entire Mediterranean basin.
Which must have been an incredible sight.
Even mainstream geology estimates this waterfall would have been geologically instantaneous, just a staggering, roaring volume of water rushing in to fill an entirely empty, miles-deep basin.
Okay, but this brings us back to the core mystery we started with.
The brine pools.
Yes. What happens to all that salt? You know, the miles-thick layer of halite and gypsum that baked on the basin floor during the dry phase. When this massive waterfall comes crashing in, doesn't all that salt just dissolve back into the new ocean water?
Well, a lot of it does dissolve.
Yeah.
But here is where we finally answer the mystery of those deadly underwater lakes you mentioned at the very beginning.
I've been waiting for this.
During that long dry phase, as the sea was evaporating, the very last remnants of water pooled in the deepest, lowest trenches of the Mediterranean basin floor.
The absolute bottom of the bathtub.
Right. And these pools became hyper-concentrated brine. Water so saturated with salt and heavy minerals that it was basically a dense liquid sludge.
Okay, so you have these deep, isolated puddles of extreme brine sitting down in the dark trenches.
And when the Zanclean flood happens, when that fresh glacial meltwater and the Atlantic seawater come rushing over the Gibraltar threshold, they rapidly flood the basin. But that incoming water doesn't churn all the way down to the very bottom trenches.
It just glides over them.
It actually sits on top of those heavy brine pools.
Wow. The UTGH introduces a very specific term for this, right? Glacial meltwater density stratification.
That's the exact mechanism. Stratification just means forming layers. The brine at the bottom of these basins is roughly 20% denser than the incoming ocean water.
20% is a big difference in fluid dynamics.
It's massive. Because of that extreme difference in density, the two types of water physically cannot mix.
It's exactly like a bottle of vinaigrette dressing.
Oh, that's a good way to look at it.
You have the heavy oil and the lighter vinegar, and no matter how long they sit in the same bottle, they separate. The denser liquid stays on the bottom, and the physics just won't allow them to combine unless you violently shake the bottle.
That is a brilliant visual. And because the bottom of the Mediterranean is miles deep, it is far too deep for surface waves or normal ocean currents to ever shake the bottle.
So it just sits there.
It sits there. That density stratification becomes permanent. The heavy, toxic brine is hydrodynamically isolated. It is permanently trapped beneath the crushing weight of the lighter ocean above it.
Leaving us with these isolated deep-sea lakes, deep hypersaline anoxic basins, or DHABs.
Basins with names like Ladalond, Bannock, and Discovery. They are completely devoid of oxygen, insanely salty, and separated from the normal ocean by a visible, shimmering boundary layer that looks, just as you said, like the surface of a lake.
Just toxic, super salty time capsules resting at the bottom of the sea.
Preserved not by being buried under solid rock, preserved purely by the sheer unyielding density of their own chemistry.
That is honestly breathtaking. Let's pull back and just recap this staggering sequence of events we've unpacked from the UTGH framework today, because it is a wild ride.
It really is. We started with the Mediterranean as the pre-flood Garden of Eden, a lush, highly productive, sheltered valley.
Then the rupture event triggers the massive Gibraltar breach, pressure washing all of that rich biomass eastward.
where it is caught and buried in the sinking Arabian lowlands, subjected to immense heat and pressure to eventually become the immersive Gawar oil field.
Then the thermodynamic aftermath, the hot oceans and dark skies, triggers a centuries-long ice age, dropping global sea levels and re-isolating the Mediterranean from the Atlantic.
Causing the basin to dry out completely into a miles-thick salt flat during what we call the salinity crisis.
Until the global ice finally melts, the Atlantic rises and breaches Gibraltar one last time, and the basin refills, trapping those dense, toxic puddles of ancient brine at the bottom forever due to density stratification.
It is a single, continuous chain of cause and effect, attempting to rewrite millions of years of standard geological history into a few turbulent, highly energetic millennia.
It entirely reshapes the way you might view a vacation spot, doesn't it?
Oh, absolutely.
You look out over the beautiful blue waters of the Mediterranean, maybe from a beach in Greece or Italy, and if you are looking through the lens of this framework, you aren't just looking at a peaceful sea. You are looking at a recently flooded
A
valley.
graveyard, really.
Yeah, a graveyard that holds the submerged, salty ghosts of a radically different ancient world.
It definitely forces you to ask, how much violent history is hidden beneath the surface of the things we consider permanent and peaceful?
Which leaves you with this to ponder. If the UTGH model argues that one of our most famous seas is actually a flooded valley hiding the catastrophic scars of a planetary upheaval, what other everyday landscapes might you walk past daily, completely unaware of the hidden past waiting just below your feet?
It's a great question.
If you knew how to read the rocks, what other quiet lakes or rolling hills are just waiting to be read through a different lens? Keep that in mind next time you take a walk outside. Thanks for diving deep with us.